So once again, we're going to be graphing our parent function as well as our transformed function. In this case, we're using the reciprocal function. So let's first review what the reciprocal function looks like for our parent. It probably looks like this. And notice that it actually has a x-axis right here and a y-axis right here. So it doesn't really go through the origin. But that's what our parent function looks like. So let's take a look at points for my parent function. So we have x, we plug in x, and we're going to plug in 1 over x. When we do that, 0 is undefined. So I'm just going to write undefined. But if we plug in 1, we get 1. If we plug in 2, we get 1/2. If we plug in 3, we get 1/3. And if we plug in -1, we get -1. And if we plug in -2, we get -1/2. Okay, so now we're ready for our transformations. Again, I'm going to look on the inside of my function, and we have x plus 3. I let that equal to 0. I find x is equal to -3. So I'm going to come over here and draw a vertical line at x is equal to -3. Then my vertical shift is going to be a shift up by 4. So I'm going to come over here and call that y is equal to 4. Next, we actually have a multiplier. Here's our multiplier of 5. I know it's weird to see it like that, so I'm going to write it again so we can see it. So we have k of x is equal to 5 over x plus 3 plus 4. But I want to show you that I can write this as 5 times 1 over x plus 3 plus 4. And remember, we would have multiplying by fractions, top times top, bottom times bottom, and that's how we end up with the 5 over x plus 3. But we can clearly see here that we have a multiplier of 5 that we're going to multiply those y values by. So I need to multiply these values by 5. When I do that, I'm going to get -5 over 2, -5, still undefined. I get +5, and I get +5 over 2. For graphing purposes, 5 over 2 is the exact same thing as 2.5. So that we know where to graph that. And we're ready to graph, believe it or not. So we have our axes there. Notice we do not have a point 0, 0 because at 0 it's undefined, and we said that over here that there is no point on the origin. So we can still see our origin. I'm going to put a slightly little blue dot there so that we know that that's our new origin. From our new origin, we're going to graph the point 1, 5. So from my new origin, I go over 1 and up 5. 1, 2, 3, 4, 5. And we can see we can go over 2 and then go 2.5 up. 1, 2.5 up. And we could do the same thing down here. That would be 5/3. If we multiplied it times 5, that's about 1 2/3. So 1.6. So I would go over 1, 2, 3, and then up 1.6. But all we really need to know is that it kind of gets closer to our axes very quickly. So we're going to say the same thing over here. We're going to graph this 1 point, go over 1 and down 5. 1, 2, 3, 4, 5. And from here, we're going to go towards our x-axis and towards our y-axis. Notice I'm not talking about the black x and y-axis. I'm talking about those yellow ones of our new axes that created our new origin. And that's our graph. Let's talk once more about our parent function and our transformed function that we need to graph. And this time we're doing it for reciprocal squared. Parent function of reciprocal squared looks like a volcano or a tree trunk. Looks something like that. And it has the y-axis going right in the middle and the x-axis going underneath it. So that's what it's going to look like. We can look at points for my parent function. We're going to see that we're going to have x, and then we're going to have 1 over x squared. 0 is undefined because 1 over 0 is undefined. If If I plug in 1, 1 squared is 1, 1 over 1 is 1. If I plug in 2, I'm plugging a 2 right here. I'm going to get 2 squared is 4, 1 over 4 is going to be my answer. And we can keep on going. I'm just going to leave it like this. Go to negative 1 becomes a positive 1, and a negative 2 becomes a positive 1/4. Remember, the negative is being squared, and that's why it becomes a positive. All right, let's take a look at our transformations. I always start on the inside. We can see x minus 2 is equal to 0, x is equal to 2. So I'm going to have a vertical axis right here at x is equal to 2. My vertical shift says go up 3. So I'm going to come over here to y is equal to 3. And that is my new set of axes. All right, all we have to do now is take a look at do we have any multipliers. And we actually see I have a negative. So what does that mean to my graph? That means that my transformed graph is actually not going to be a volcano going up. It's going to be coming down like this. All right, so let's see if we can expect that in our points. So notice we have a negative 1, so we have a multiplier of negative 1. So I'm going to have to do a negative of these values. So I'm going to have a negative 1/4, a negative 1, so I'm just doing this. Multiplying times 0 is still undefined. 1 times a negative is a negative 1, and a negative 1/4. So now we're looking at our graph. We're going to go to our origin. I'm going to put a little blue dot so you know that's my origin. I do not have a point there, but I'm going to go over 1 and down 1. I'm graphing this point, over 1 and down 1. There's my x value, here's my y value. So I'm going to go over 1, down 1. I can go over 2 and down 1/4. But really, truly, we notice that it's just going to go towards my x-axis and towards my y-axis. Again, I'm going to graph this point right here, which is negative 1, negative 1. So I'm going to go to the left 1 and down 1. And then from here, I'm going to go towards my x-axis and then towards my y-axis. And we're done. That's our graph.